In these examples, we're going to look at some equations, and by looking at the equations, we will determine whether the function is linear or nonlinear. So let's review what that word linear means. We know that it means it's going to be a line, and we also know that it means it's going to have a constant rate of change. Also, if a function is linear, the equation should be able to be written in this format, which is the slope-intercept form. So if you are able to write these equations in slope-intercept form, then they can be identified as linear functions. So let's look at this first example, y equals 3x plus 4. This one is really nice and really easy because it's already written in the format y equals mx plus b, where 3 is our slope and 4 is our y-intercept. So I'm going to go ahead and circle the word linear because this is a perfect example of a linear function or a linear equation. Looking at example 2, it's a little trickier because we don't have the variables y and x, but that's okay. You can have linear equations with different variables. And the format looks a little bit different, but if I wanted to, I could rearrange it and I could write it as g equals negative m plus 3. By rearranging it, now I have it written in slope-intercept form, or y equals mx plus b, where my slope is negative 1 and my y-intercept is 3. So this is another example of a linear function. Example 3 is a little tricky because you don't see that variable x. And so you might jump to the conclusion that this is not linear. However, let me go ahead and rewrite it in this form, 0x plus 4. And the reason I'm doing this is because I want to show you that when you have an equation that's just y equals a number, this is actually an example of a horizontal line that crosses the y-axis at 4, okay? So I'm just going to draw a quick sketch of a graph here. Let's say that this is positive 4 on the y-axis. This equation stands for the horizontal line that crosses the y-axis at positive 4, which means that it is linear. It is a line that has a slope of 0. So I'm going to circle that word linear. Example 4 says y equals x squared. Can I rewrite this equation in the format y equals mx plus b? I cannot. Because there's an exponent here, there is no way to rewrite this in that format. This is an exponential function, so this would be non-linear. Example 5, again, I can already tell right away that this is not going to be linear because we have an exponent. And you cannot write an equation that has an exponent in that format, y equals mx plus b. So this would be an example of a non-linear function, and this is an exponential function. Lastly, example 6, we have it as y equals negative 1 plus 2x. Well, really, all I would need to do to rewrite this in the format of y equals mx plus b is just do a little rearranging, and I would have it as y equals 2x minus 1. Now it's in that form, y equals mx plus b, and I can easily see that it is a linear function with a slope or rate of change of 2 and a y-intercept of negative 1. So that's another example of a linear function.